So let's see, masters in IT, we'll just move on, right? Okay, so in the previous sections we talked about what was required to create the basics of a network. That is to say that we talked about what was, you know, the basics of networking, what was the basics of cabling and connectivity. We talked briefly on the hardware that was required, and then we talked about the setups that were required. And I even went as far as to show you the setups that are required. In fact, I'd like to be able to show you the setups on that today. Hopefully, when we get to the end, we got some Q&A stuff. We'll probably have a couple of mind-blown moments in this one. This one's going to be really wonderfully functional, I think, for a lot of people. So let's go ahead and begin on that. What I'd like to do is I'd like to start about talking about TCP/IP. And I'd like to go into this like we went into WINS. Now, on the plus side, there's a lot that we can build upon now, so hopefully it'll go a little bit faster. I do want to mention this. There are two different flavors of internet protocols out there, TCP/IP. There's TCP/IP version 4. Yes, I don't know what happened to 1, 2, or 3, but we're using 4, right? And then there's version 6. No, I don't know what happened to version 5. But the joke with Windows is there's 7, 8, 9, right? That's why there's 10, right? So moving along, let's just go through TCP/IP version 4 for some reason this is not listed. We can go on to the next. Oh, the area of focus. That's why. You need to take the mouse and click here, and it knows where to go. Okay, very good. So here's the deal on TCP/IP. You've been using it. Well, you've been using the internet, right? So you have to use an IP, whether you do it or not. In fact, actually, we were using something called DHCP, which is Dynamic Host Control Protocol. The letters aren't going to really tell you what it means, other than the word dynamic is really important. It is the router is setting your IP for you. So you were able to create, like let's say you create a WINS network. WINS in the background says, hey, I'm also going to need an IP, so router, help. Can I have an IP? The router goes, yeah, here's one that's not being used. And you can use this one for a lease. And a lease is just like it sounds like so far as renting. You don't own it, right? It's not yours permanently, but you can use this during this time. And that's exactly what a lease is. So the big thing there is that it's dynamically set. The bad thing is things that are dynamic means changing, right? Now, imagine this to be a phone number. And let's give this phone number to your buddy, we'll call it CT number 1, right? And your buddy CT number 1 keeps getting a different phone number every 12 hours. How much fun is that? You all have that friend that keeps losing the phone, right? And they have a different number every other month, and you don't know how to get a hold of them. Now, that's not bad when it's your drinking buddy, but that's a problem when it's your CT machine, right? So that's why we don't use DHCP. We want to use something at the bottom here. You'll notice we use static, okay? Static IPs are much better because they don't change. So we're going to actually have to set IPs and things. You're going to need this, particularly on your imaging equipment, a lot of your hospital support equipment, your monitors. It'd be really nice to know which monitor I'm talking to, right? Things like that. So these are just sort of the basics as to how to make this happen. So we do use this stuff on top of WINS. It's important to see this as a separate protocol. So everything that was working on WINS will continue to work because computers have no problem talking in 2 protocols at the same time. They're fully bilingual. In fact, actually, they can be programmed with all the languages. And they can keep talking all fluidly and simultaneously. How does that sound? That'd be a nice gift to have, wouldn't it? So, moving along here, let's go back to the basics of networking. Remember when we covered WINS, we covered the basics of networking. We talked about the group, and we talked about the individual number, right? So there was a way to identify the group and a way to identify the individual number. I want to rehash it. Remember, the way to identify the group has to be the same. We have to be in the same group. We have to have a different identifier for the individual. So that's very important that we talk about those rules, because those are consistent throughout all of networking. And we've already proven that, right? So let's talk about an IP. I've got a group with the area code and the city code. I've got an individual number right there. But check this out. When I've got an IP, I use the IP and the subnet to tell me the line. There's a line between the group and the individual. Only we're not going to call the group a group. We're going to call it the network section. And we're going to call the individual the host section, much like computer name is a host name sometimes. So the host is the individual, the network is the group. And notice we comply with the same rules. By the way, does anyone want to give me an IP that would work with this machine? Based upon those rules, what must my IP start with? 172.16. What can I not use for an IP if I'm already using that number? Can't use that same number. Have to use a different number. I can use .1.102. I can even use .0.102, because notice it's just like changing a couple of the sections of the number. You gotta change at least one. After that one, on the right-hand side, that one. So there's the group, there's the individual, and there's a bad cut and paste. Okay, so moving along. Now, you've seen this. These are the classes. There are the lines. You've seen networks start like this. Maybe if you've worked a little bit with TCP/IP, you've seen these numbers. If you haven't, this is a very important slide, because this shows you the general IP scheme for most networks. So the rule is just this simple. Look for the change in the subnet. When it changes from 255 to something else, draw a line. Now, notice I didn't say if it changes from 255 to 0. I said when it changes from 255 to something else. And we're going to go over that in the next presentation. But for now, let's just keep it simple. 255 or 0. I draw a line after that. And when I'm done drawing that line, I know where my network portion is, where my host portion is. And I know that I've got to keep the network portion the same and the host portion different. And my device should be in that network. The hard part is this, folks. When I say that the host portion has to be different from everyone in the network. Again, keep in mind, we can't have two people with the same phone number. We can't have two people with the same IP. You've seen this. We call it an IP conflict. If you put a machine together on a network and it has the same number as another network, the network is working fine until it tries to get a hold of that number. Then it gets two answers. Then they spaz out. Then the network twitches, and then it resets itself. And then it's fine until you need that number again. And then it twitches out, and then it resets itself. And you've seen, why is this network bouncing? Why is it going up and down? It's up and down, it's up and down. I'll tell you why. Because somebody's got the wrong IP. Somebody's got a naming conflict. Someone's using the same work group and the same computer name as someone else. Or someone's using the same IP, the entire section, as someone else. Golly, those are hard days of troubleshooting. So here are lines between the network and the host portions. Remember the rules, and you'll be fine. Look, folks, that's TCP/IP in a nutshell right there. Got a question?
Yes.
Sure.
So you said that.
Okay, going back to the last slide.
So everything, all I'm saying that number one.
Yep.
I must have missed the network.
The network number is the group.
Okay.
So the group, the network portion, see where it says network in the first portion? Yeah, that is our group. You have to be in the same group. And again, I want to stress, this is a group, networking basics part 2. You can all hear me because you're in the same room. We're in the same group, right? And it's just that simple. Exactly the same rules that we're applying right now to this conference, right, are applied in this network. So moving along, I'd like to describe what I'm using, because I'm not using just any random IP number here. I'm actually following the rules. What are the rules? Well, first off, I'm going to tell you right now the rules are voluntary, because this is not on the internet. This is inside my hospital. So technically, I can pick any number I want, as long as it's between 0 and 255, and put it in any one of those things, and we should be okay. And I can cover lines between 0 and 255, but we have to go back to binary. Okay, so you all remember binary, right? Yeah, it's been a while since I've been in school, but you can look it up, right? So if you look it up, you'll find that 255 is 8-bit. 0 to 255 is a limit of 8-bit. That is one 8-bit number. You can represent that in an even scarier than hexadecimal, right? You can represent it as 2 Fs, a 15 and a 15. So that's why 0 to 255. So the first IP, that is a class A IP, you'll notice that I've got 3 sets of 255 in the host, which will give me up to 16.7 million individual machines that can be on that network. That's a big hospital, isn't it? Bless you. Again, if your name is VA, that's not enough. So before you sit there and say, man, that's a lot of numbers, we're never going to need that. Really? Taylor, how many facilities are you at now? Too many? What was that, 50? 23? Oh, I didn't say hospitals, I said facilities. Way more than 23, right? Double or triple that. Each one has a network? Okay. So you get my point. How many machines do you have? Well, is 16 million really enough numbers? And this is what we're seeing. We're seeing more and more hospitals going under a bigger scope. So we're seeing bigger and bigger number schemes. Okay? So if I start my number scheme like this, I start with a 10, everyone will understand that's not an internet number, that's a local number, and we're good. Follow the rules, and everyone will understand you're not on the internet. Nowhere on the internet does 10, 172.16, or 192.168 occur. We've put that for local traffic. Here's the bad part. Look at this bottom line right here. IT compliance is voluntary. Do they have to follow the class rules? Nah, they can make up their own numbers. That gets really confusing then when you lose staff. Right? Don't cowboy it, just follow the rules. Sound good? So here's how this works to your router. Now, a router is an interesting device. A router makes the decision a switch doesn't make. Remember, a switch is concerned about MAC address. Routers are not concerned about MAC address. Routers are concerned about IP. Routers understand 2 things, inside or outside. I'm going to say that again. Router understands 2 things. If it's inside the LAN or if it's outside to the internet. That's the purpose of the router. The router is what's called a gateway. Okay? You want to write that down too. Router is a gateway. Gateways control inside to whether the traffic's inside or outside. I'm going to give you a little bit of time to write that down. Very important principle. Here's why that's important. If I get this IP, I get this 192.168.0.105. Is it local or internet? Well, if they're complying to class rules, this is local. I bounce it back. I get this transmission. Doesn't look like anything local, does it? There goes the internet. Now, I'm going to be honest. I just glossed over a lot of really technical stuff in a very simple oversimplification that is pretty accurate. Okay? Think of it this way. If you're following the class rules and you know that these certain IPs are not on the internet, you know these certain IPs that are, in the classes probably are internet, that's a pretty simple way of looking at it. Right? And a router makes this decision like a billion times a second. That's what a gigahertz is anyway, isn't it? So it's just that simple. So how do we set it up? We're going to go through and we're going to set this up. We're going to go through and we're going to do a lab and we're going to show you how to set that up, and maybe I should be doing that now, I don't know. But clicking on this, you'll be able to, clicking on this, you know what? No, maybe we're doing this. You're getting full service today. Why not? So I'm going to hit my, where did I set this up? I set it up here. I right click. I need to magnify. I'm going to magnify. I'm going to right click on my network icon here. Notice I got one for wireless. I'm going to click the open internet troubleshooting. Yes, I know I got a shadow thing that tells me to activate my Windows. I blame STC on that one. Let's move on. I'm going to go to my Ethernet adapter. Well, let's go to my Wi-Fi. You know what? Let me go back to where you normally see it. Now I'm messing myself up. There we go. This is what you would normally see when you click on this. One of the things that you're going to have is you're going to have change adapter options. You click on change adapter options, and now it'll take you to where my slide is. I'm going to go ahead and I'm going to right click on this, right? I'm just going to go ahead and click my status. And notice it's got my status right here. I can go ahead and hit details, and it should give me my IP and all the stuff that I need. By the way, it's easier to find this through your command prompt, but notice here it's got my IP address. It tells me my subnet. Notice my subnet has a line here with the 255 because there's a change there. Notice I've got another change, so there's actually two lines, and we're actually going to cover that. We're going to cover what that means. Notice we almost look like we're a class B, but they changed something. Why? Because it's voluntary, and I don't want to change it. Why not? Trust me, the router knows these IPs just like the switch learned all the MAC addresses. The router learned all the IPs. Yes, sir.
It wants to do that 2 zeros, and it wants to do that 0 2 0.
Yes, the 0 is implied. So yeah, you'll notice 0 0 1 or 1, they're the same thing. Notice I've got some other things in here like my MAC address. There's my physical address. This is that IPv6. Yeah, you're going to be lucky or happy to hear this. You don't set IPv6. It pretty much is one of these things that you can just work with for connectivity. And this is sort of something we're going to in the future, but right now let's just focus with IPv4. That's enough to worry about. So how do I make changes? Well, I can go to properties. If I click properties here, it should bring up an adapter settings. Notice these are all the protocols that my machine is talking with. I can go here to IPv4 and hit properties, and notice here it allows me to set in my IP. Now normally I would set in my IP, but I can guarantee you that the router I'm currently connected to is using some security settings, right? And setting the IP, well, I might flip it out even if I grab one that is, available. Worst case scenario, I grab a number that is currently being used and I cause the network to sort of spaz out, as we've talked about before. And one of the worst things is I'm streaming right now, so if I make a change to my IPs, I'm going to have some problems with the stream, right? So we're not going to make any changes to the IPs, but we will look a lot at some things today, okay? So notice when it says obtain automatically, that is my DHCP server. So I'd like to go back now to the presentation. where was the presentation? I lost myself, didn't I? We're going to go ahead and I'm going to leave that up. I'm going to go to here, and we're going back to our current slide. There we go. So these are all the settings that you were looking at. Now you know where to find them. Now you know how to do that. Now it's all been recorded, so you can walk through it, right? Notice here you can set in your IP, you can set in your subnet mask. Notice I'm using the word your subnet mask. One of the biggest confusions that I get from people is I'll tell them, hey, this is the IP scheme that we're working with. Here's your router IP, 172.16.1.1, right? So they go to their IP address and they enter 172.16.1.1. Because I'm the router. You are now, right? And then every time someone wants to talk to the router, the network crashes. Guess how many times they talk to the router? Billions of times a second. Don't put someone else's IP here. Put your IP. Put the IP for the machine you are working with. It's really easy to keep straight if you think of it like a phone number. It's just a phone number. But no one shares the same phone number. Not unless it's on purpose, right? So you put in your IP, you put in the same subnet, because the subnet teaches us where to draw a line. If we're going to draw a line in a network, draw a line in the same place everyone else is. Because that's what helps us make sense of the network, right? Don't cowboy that one. That one is the same subnet. So, they're not the only settings. By the way, I think at this point in time, it's important for me to show you something as far as the basics of the structure of a common network. This one right here would be a radiology department. I have a radiology department set up, and all these servers are set up to it. Notice I got a HIS-RIS interface, which is there, so I'm pushing back and forth to HL7. And this is basically bread and butter if you work in radiology. This is pretty common. Notice I've got somewhere a file server tied to it with some form of an archive service and some form of a RAID. Does anyone know what RAID is? RAID is a whole bunch of hard drives working together as one. That's a nice oversimplification. By the way, I can do that with what? Up to 25 hard drives in one machine. I've got plenty of network ports. I can drop more on if I need to. And you know what the scary part is? Imaging is a hungry beast if you can never feed enough. You ever notice that? No, seriously, you can open up and go, hey, guess what, guys? I just gave you 100 terabytes. You come back in a week, it's gone. You can never have enough storage. I don't care who you are. The only people I've ever met or heard of that had enough storage were the big players. The person that actually had enough storage was Amazon. Amazon has racks of hard drives in a semi. They put about 4 or 5 semis together. They have exabytes of storage. You know, they at one point in time somebody asked, well, how much data can you store? They went, all of it. They weren't laughing. They have put so much money into their infrastructure. They have enough storage space to hold every image and every record for the world. And when they need more, they just buy it. And it's scalable. This is why I mentioned that. Thanks to them, this is what your radiology department looks like now. Why should I pay to have all that storage on site when Amazon will do it for me cheaper? Why not just buy their storage service and push all of our data through the web to them? That's what I'm doing here. I've got a network. I've got all my radiology tied to a switch. It goes to a push gateway. It's a gateway to router. Goes to the internet. Goes through the internet to their systems. And a company that can pool resources is storing all of our images. Well, this is fine until we lose the router. This is fine until we lose internet connection, right? This, by the way, folks, I love to say this is the future. This isn't the future. This is 3 years ago. Okay? So, we need to know IPs. There's one more setting we didn't cover. I don't know if you didn't notice it. Let me go through this whole spiel, but I'll tell you it's the domain name service right at the bottom. See, this is our BET-MIT page. You notice I do a lot of promo for the school I teach at, right? And so this is our club. We've got a lot of our students here. If you're hiring, by the way, you can go ahead and talk to them over at the club booth, and they'd love to talk to you. We've got a lot of people that are going to be graduating like in a month. No, actually, it's not a month, is it? It's 2 weeks. So some of you all that might be valuable information too. Here's the deal. This page, this is the Facebook page. That's not how a computer thinks. They don't dial Facebook. You dial the number. This is the number for Facebook. You can actually put that number in your web browser, and it'll come up. Unless they changed it on me. It ain't dynamic. So, Facebook is a name, right? Think back to your phone now. You go to your phone. How many of y'all actually remember everyone's phone number? No, that's why you got a contacts list, right? You got a contact list so that you can actually find that phone number. The internet has a contact list. We call it the DNS. You know how many phone numbers there are on the internet? Billions. You gonna remember all those numbers? Is your computer gonna remember all those numbers? Your computer doesn't even remember all those numbers. Your router doesn't even remember all those numbers, but your router talks to another router, and that router might remember those numbers. And if that router doesn't remember those numbers, well, it talks to another router. And I'm going to ask routers over and over and over until I finally find a router that's got the answer. And I'm going to do that billions of times a second. I'm going to do this so fast you won't even notice anything. And all I'm asking is a simple thing. I'm going to say, hey, I got this name, it's called Facebook. What's the phone number for Facebook? Well, I don't know. Ask the other, right? And that's exactly what it's going to do. And that's exactly how DNS works. Now let me ask you this. How important is that contact list? That is like everything to you, isn't it? So, you go ahead and you put in the name, you go and you get a number, it's returned from the web, your web browser goes to that number, you get to look at silly cat pictures. Because that's apparently what Facebook was for, right? Or at least a good portion of the internet. That's pretty cute. Come on, let's move on. Okay, so here's where you set these two really important things. You have to know to set that gateway. The gateway is what IP, what machine is the gateway. Well, remember, it's the router. Fantastic. So you've got your IP, you've got the subnet mask that hopefully everyone in the network's using, right? You got the gateway, which is the router. You got a DNS, which, hey, which machine will have the context list for the internet? Which machine's the best machine to ask? The router. So go ahead and put, for most purposes, you could go ahead and put the router in there, but you don't have to. Here, I didn't put the router IP there. I put an internet IP. That's nothing local, is it? That's nothing local. That's Google's DNS. Google has a DNS. They just leave it flagged out there. Anyone can grab it. Just hang out. So how restrictive is Google? They don't restrict anything. Here's why Google started doing this. How restrictive is China? China wanted to handle the DNS list for everyone. The whole world. They were very, very eager to do that. They'll forget certain things, like, I don't know, the word freedom. I'm sorry, I don't know what that means. You get the point. Controlling that contact list is controlling the network. How many of y'all got kids? You want to write this down, write down Open DNS. Open DNS is what's called a dynamic DNS service. You can actually pay a company to do things like forget what to do when your kids ask for porn. You might appreciate that. You might want to go home and set up your IP addresses to, I don't know, go to that DNS instead of Google, because Google doesn't care if they refer that to your 12-year-old. I'm not kidding. Is that going to help you? Hopefully. By the way, that's also what your IT department does. If I want to know where you're going, all I have to do is look at your DNS requests. That's pretty straightforward, isn't it? All I got to do is log that. Which IP, which MAC address, which login, who was logged into that? Hey, Active Directory. Who was logged into that machine at this time? You see what I'm saying? This is how they catch people doing bad things. Moving along, let me get weird things, and I think it's a good time to go on to another presentation to show what happens when we get weird things. What's weird about this IP? Well, the IP is not weird. How about the subnet? Subnet's got two changes in it, doesn't it? Not one, so there's two lines. So this is what your IT department's going to do to you on a regular basis. Here's how you figure it out. You get what's called a subnet calculator. A subnet calculator will help you make sense of this. We should have internet access. I don't know if I can go to a subnet calculator or not, but I've got the link right here. So, well, that was bad. Oh, there we go. I'm going to click, right click, and follow link. Open hyperlink. Yay. Here's a subnet calculator. I'm going to do my magnify. Oh, there you are. I lost my own utility. Here we go. Come on. There we go. Zooming in here. Notice I've got Class A, Class B, Class C, right? And each time I change it, outside of it having a slight lag because I am streaming, it does go ahead and it changes things. Let's go ahead and we'll do a drop down here, and I'll put in my subnet, and I'll put in my IP, and notice what we got here is we've got the number of networks that I can have, the number of hosts that are on here, and then it even tells me how to use the first range group. So I need you to do something for me. If you're going to work with any IPs, and you probably carry a cell phone or a smartphone with you, I'll get out of the way for the pictures while I'm taking pictures. So on your phone, you can download an app, IP Subnet Calculator. All those times that people in IT were sitting there confusing you by having all of those numbers, and you didn't know which number they were talking about, you could have used a calculator and kept up with them. In fact, most of the time, what you want to do to translate, to figure out an IP, you just want to have a calculator. Look, they're just good with hardware, folks. They're just familiar with the network. They're just familiar with the tools. I need you familiar with the tools. They're going to do something funky. They're going to do these mask bits. So let's go into our next presentation, and I'll show you what is meant by that. I hit the escape key. I shouldn't have done that. I should just zoom out. I should leave that up. I'm going to go ahead and go to my next presentation, which is how to do VLANing. I keep doing that. Start show from the beginning. So let's talk about some of the things that you've been dealing with from a professional standpoint that have been really confusing that IT has been throwing at you. Because I hate to say it, and maybe I'm oversimplifying, but if you see IP as a cell phone number, this isn't hard, is it? It's just you've got a local area, and then you've got a internet area or a long distance, if you will, right? The long distance is that if they're changing that network portion, the local is the local numbers on that host side. So let's go back to that. Remember that you have that network portion, you have that host portion. You have that long distance portion would be changing the left-hand side of it, right? And the local will be changing the right-hand side of it. And it's just that simple. So let's look at that example that I used from the previous presentation. We're going to change the subnet. And I know that in the write-up here, I got a slightly different one when I think about it. I probably won't change that. But the truth of the matter is, look at the bottom graphic here that I've got with area code, city code, and individual number highlighted. Think of it that way. Now let me ask you this. If you have an area code change, you know you're going long distance, right? Does anyone pay long distance anymore? This model only works for people who remember paying for long distance. So if you ever paid for long distance, you'll remember this skunk. Because every once in a while, you were in the same area code, and you changed that city code, and it was long distance. And you got billed extra because you changed the city code. Well, that's exactly what happens here. You have a network portion, you have a host portion, we're used to that. Network portion is the one like the area code, host portion is like the individual number, but now we have something called a subnet range. And now we're in that, well, is this city code long distance, yes or no? Depends. These numbers are, these numbers aren't. So how do we figure this out? Well, first off, it's dictated by the subnet mask. Now, just to break it down, these are what the different subnet masks are. They're not a complete list by any means. It's just a small little sample. But what's driving this is that first column. How many sub-networks do I want? Now, how do I know I want a sub-network? Well, let's say I've got lab, I got radiology, I got patient monitoring, I got surgery. I want to section those off into separate areas, right? I want to section those off into separate areas so they become smaller networks in my big network. And that's the point here, to make smaller networks in my big network. Notice the number of hosts. As I increase the number of sub-networks, I actually decrease the number of available hosts. Can't steal from one without having to sacrifice from the other. It's just that simple. So I really have to consider how many machines are in this network. Now the really confusing part is this mask bits. This mask bits is driven by the binary math. How many ones and zeros do I have? And in fact, actually, specifically, how many ones do I have? Now that doesn't make much sense. When you think about it as this. Subnetworks, those are the number of networks I want. Let's look at the top line. Binary, if I were to turn that number into binary, it's that, right? Now, it's sort of, I'm not going to go into why. Subtract one and flip it. Subtract one and flip it, that makes it one number at the very end. That number, if I were to turn it into subnet, or into decimal, would be 128. If I were to count the number of ones, this is 8 for the first 255, it is 16 for the next 255, it is 1 for that 128, giving me 17 total ones. Now, here's why this is bad. Your IT department's probably not going to tell you the subnet. They're going to tell you the mask bits, because it's a shorthand for the subnet. And they figure, if you know what you're talking about, you'll be able to figure this out. If you can't figure this out, fire up a calculator and figure it out. Going back to that calculator, you'll notice in that calculator, and hopefully the machine doesn't get angry at me for flipping back and forth. Well, okay. In that calculator, they actually talked about mask bits. So let me just go back to this. Sometimes flipping back and forth is worse than it's worth. So they talk about the mask bits. Notice here for my network and my host, that, by the way, what I've broken down there, that is actually what the subnet looks like to the machine. Because the machine doesn't understand 255 or 240. You're decimal. You've got 10 figures and 10 codes, and that's why we count 10, right? And that's why you use decimal. Honestly, I'm not kidding, it's just that simple. Computer uses yes or no, on or off, 1 or 0. So to a computer, there's only one division. There's only one line. And when your IP crosses that line, you're in a different network. So this is, by the way, a /20 network, because there are 20 ones. And the network, the subnet itself will be, if you look at 20 ones, there are 4 bits, so it's the 4th line, so it'd be 240. So the correct decimal subnet would be 255, 255, 240. I hope this isn't too much of a deep well, but what I really want you all to understand is, if you use a calculator, this will be much easier on you. If you want to do math by binary like me, and you really love the science of it, well, you know, first off, when you want to work for half of what you're worth, come see me. You could use another instructor, right? No, I'm just saying. I mean, if you like the science of it that much, teach it, right? So the subnet is actually 255, 255, 240, but that's not what the machine sees. The machine sees 1s and 0s. There's the line. The line's very clear to the machine, right? But to you, 255, 255, draw a line because it changed. 240, draw a line because it changed, right? Network, subnet, host. Simple, right? So this is why we do it. This is a graphic that I found online for somebody who was talking about a doctor's office. Notice the internet goes to a router, then it goes to a switch. Notice I got my servers in that first switch where everyone can see it. I got some doctor's offices going to their own switch. Then I got a backbone going to all my sub-departments. How many networks do I need? If you want, just count the boxes. Like what, 6? 1, 2, 3, 4, 5, 6. We need 6 different networks, right? Well, I mean, you're not going to get 6 different networks, are you? Here, let's go back a little bit. We're not going to get 6 networks. Which network are we going to get? 8. We can do 8. So we'll do 8 networks. So our subnet is 255, 255, 224. In the /19 network, there are 8,000 users that can work in each one of those 8 networks. See how nice that is? It's sort of nice to have these charts around, isn't it? And you can look online because guess what? On there, I've got a subnet IP chart right there. Because this is by no means a comprehensive list, but that one, pretty good. You might want to download these presentations, right? Just the links alone on this one makes it worth it. Okay, so going back here, notice we put it into our subnet calculator. We calculate this all out, and we come up with the same answer. The subnet calculator is going to tell us, go ahead and use this network. Go ahead and use the 255, 240 network. But your IT department isn't going to tell you they're using that subnet. There you go, well, it's a /1G network, you should know that. Thank you. Let me just put it on a calculator. Okay, yeah, I'm with you, right? And no, seriously, the conversation can be that simple if you have the right tool available to you. If you have a smartphone, this is an app. Just get the app, right? So let's go on to something else that you're going to deal a lot with. VLANs. Because you know what? If I've got all these separate networks, well, I might as well have separate cables and separate switches, right? So VLANs look more like this. Let's go on to this for the next thing. By the way, VLANs are used mainly for switches. I got it bold right there. The VLAN is for the switches. Why? Because they go from the network to the left to the network with the right. Look at how the switches change. Rather than using a network where I have separate switches and separate cables and a lot of wasted ports, I'm going to go ahead and I'm going to tag a port. And I'm going to say, hey, this port is VLAN 10. This port is VLAN 20. For some reason, they always count 10, 20, 30. I guess we're back to Apple programming. We brought up Apple earlier, right? It's basic. Yeah. So anyway, if anyone can remember that, obviously you're a child of the 70s, if I may say so. All right, so notice here, what I've done is I've replaced 6 switches with 2. And functionally, I run the traffic separated in each one of those networks. All I do is I tell the switch, hey, this port is tagged VLAN 20. Keep that data separate from VLAN 10 and VLAN 30. Switch was over. Switch is really just a really quick mail sorter. That's all it's doing. It's sorting messages. Oh, this one's tagged 20. It only stays in 20. Okay. You know? And that's all it does. That's all it thinks. So here's how you do this. You do tag things. Notice on the top there it's tag switch A, switch B. I got 2 cables between them, right? And that worked. That worked really well. But it was like using half the switch for one network and then the other half the switch for the other network, right? And then Cisco came up with a really great thing. They called it a trunk. Everyone else had created a tag VLAN NOC, right? So the thing about it is it's a trunk. Notice that one port, or that port 8, it's all VLANs. So what you do is you basically, they tell the switch, hey, let all the VLAN traffic use this one thing, and use this to communicate to the next switch. We're gonna do that, right? And that's all it is. And then on the other end, guess what? The message is still tagged. The message is still tagged. Hey, this goes to VLAN 20. If that switch knows what VLAN 20 means, it goes, okay, these ports are VLAN 20. And it just sorts. That's all it's doing. So it really didn't change its function. We just put a little bit of a process in front of it. But the big thing with VLAN, the most important thing for you to remember is we're just cutting down on the number of switches we need. Right? That's why we're doing VLANs. You might actually have to deal with that. By the way, does that mean that each VLAN has essentially its own subnet? Yeah, actually, they probably are doing it that way. They probably sectioned each one of the VLANs into its own subnet. So we're combining all these different things. Finally, what I like to talk about is I like to talk about port forwarding. This is really important for those of you who like to play video games. And those of you that want to send data over the internet. I'm just saying. Okay, so the thing about it is this. To understand port forwarding, you have to first understand that what I'm going to do is I'm not going to start talking about the port on the switch or the port on the router. I'm going to talk about software ports. Now, software ports, the best way I can explain software port is it's like an apartment, whereas an IP is like an actual address. It's an address, right? So I have an IP address and I go to an apartment building and then I've got all these small little apartments. Well, think of it this way. If in each one of those apartments, or each one of those apartments was a piece of software, let's say web browser. Web browser is on port number 80. That is to say I go to apartment number 80 in IP number 172.16.20.43. Whatever, whatever the machine may be, right? I go to the correct location. This is how an operating system separates data for software. In fact, maybe I should just keep that as a simple definition. This is how I separate the data on my operating system. So some of these are really important to you. Most of these are important. DICOM's got like 4 different types of ports that it uses. And this is by no means a comprehensive list. And there's the reference to Wikipedia if you want to look up more information on ports. But here's the most important thing. Port forwarding is used to let data go from one network to another. I know, for example, if the port is using a certain number, that it's data meant for a certain piece of software. Let me say that again. If a port number is a certain number, it is meant for that type of software. So should I let it in my network or not? Well, for my son, for example, he had an Xbox. You might even remember this. We were watching Hulu or Netflix or something like that, and then all of a sudden somebody started talking to our son over his Xbox, something like, "We're getting killed. We need you to log on." That didn't sound like it's part of the movie. And then they started insulting him, something about get off your lazy butt and get online, right? And that was the gist of the message. It wasn't as clean. So how did somebody talk to us as a family on Monday night, talk to our son through his Xbox? Well, the conversation didn't start inside our network, did it? It started outside our network. But I told the router, whenever voice traffic for a certain port, and I can't remember what it is, 34 is what I remember, 34, 6 something, and Microsoft puts it on their website, whenever you send traffic to that port, it's meant for the Xbox voice. So I told my router, when you see this traffic coming in, send it to this machine, and here's its IP. And then I made sure I told the Xbox, here's your IP, don't change it, right? By the way, that's exactly how you do it in the hospital. So, data came in from the world, hit my router, because it was using port number, I knew it was meant for this machine, I forwarded it to the machine. By the way, this is exactly how a firewall works. So every time you heard the term firewall is just literally going, okay, this is data coming in from the internet, it's meant for port what? And it goes to which machine? Well, what happens if you're not on the list? Blocked. That's it. That's exactly how port forwarding works. This is not difficult, is it? By the way, every time that you saw IP, then they use a colon and then a number. That colon and a number, that was the port. Just like slash and then a number, that's a subnet. Colon and the number, that's a port. So you get into a router, you can actually do port forwarding, right? You tell it, these ports need to go to this internal address, and then you can write a description for it. And just like when I said, this is the name of my share, you can write down whatever you want in the description. It doesn't have to be a specific thing. There is something called DMZ. You might be tempted to use DMZ. DMZ makes everything easy because it just takes one machine and throws it out there. All ports go to this machine. Hackers love that because you've just given them access to all software. Somebody explained to me that a port forwarding is like putting a pinhole in the brick wall that is your firewall. So you're going to put a pinhole in there and somebody can see in, but you can only see that one thing you wanted them to see. That's it. Nothing else. And then you just basically tell that program, hey, you understand this type of data. And then when it gets data it doesn't understand, it goes, I don't know how to talk to you. So it doesn't. Make sense? Port forwarding and firewalls go hand in hand. So, end goal. This is what I like my students to do in lab. We're going to do more of this. We're going to set up a router to the internet. We're going to go to the switch. We're going to set up a router. We're going to set up a router. I'm going to put clients behind one of the routers in a different network than that one. I'm going to use different subnets. I'm going to make people talk from one network to another network. This is exactly how they're doing it in your hospital. We'll say that again. We're going to have people talk from one network through their router into another router to a server. Sound good? That server can have a completely different IP. Most likely, it's on a different IP subnet. And use the router to make the bridge the gap between them. So if you want to go home and create your own network and do this, whatever, you can go to Goodwill, get some cheap routers to make this happen. And that's a good little way to experiment a little with your stuff. Put a server behind the router and then try and talk to another client through that router. Interesting, huh? But know that that's exactly what we do in a hospital. By the way, how secure is that? I'm running a firewall on the internet access. I'm running a firewall right before the server. I'm running a firewall right before my clients. Access restriction at each point. That place is like crossing the no man's land, isn't it? It really is. Hence the term DMZ. It's a military term. It's militarized zone. It's the area that is basically everyone's gunning at and no one should be in. And And that's exactly how it works in networking too. So, when you bring it all together, let's talk about what we reviewed. We talked about subnetting. We talked about using LANs, and we talked about using port forwarding. And they're really just concepts, right? How are you all doing? You ready for wireless? Wow. Are you sedated already? You put something in the water. All right. I know this was very deep, wasn't it? We're at 12:30 already. Shoot. I wanted to go through TCP/IP, and I went through TCP/IP, didn't I? I'm going to go through wireless real quick. If you want to take off and get something to eat, I wholeheartedly understand. Timing is always a problem with every presentation, a challenge, I should say. Let's go through wireless. I promise I can do this in 15 minutes. Okay? Going through wireless, really, it's not too bad. You know why? Because with wireless, all we do is replace cables. That seems pretty obvious, right? It's wireless. We disconnect the cable and it still works. So, that's all that we do. Two things that are scary. It's affected by noise. I'm trying to say it both at the same time. It's affected by noise, and anyone can hear it. Those are two things that are really scary. So you've seen the access points. They look like fire systems, right? When they didn't look like fire systems, kids were trying to jump up and rip the legs off. When they looked like fire systems, kids didn't want to be the kid that's hanging from the fire system when the alarm went off. So, you know, they didn't do that. So notice up at the top there, we make the network adapters look differently. They can be look like Bluetooth, really. And the wireless routers, I'm sure you've seen them. They're routers with antennas on the side. So settings, there's a lot of different software. The first one there is the link system. I'm going to do a lot of my stuff, and I do a lot of my stuff in the lab on Tomato. Tomato is a hacked up version of software, but it's a much easier tool for me to teach people on because it puts all the settings in one sheet. Notice there I've got the WAN side of the router, that's the outside of the router, I've got the LAN side of the router. I am running a DHCP server, that is, the router is setting IPs for the clients, and then underneath that I've got the wireless portion. We're going to focus on that wireless portion. This is sort of a common software that you would use. This is probably what you're dealing with or something that you would see at home. This is much cleaner, as I pointed out. So moving down to those wireless settings, there really are just a couple of things that you have to know about. You have to know about mode. You have to know about the SSID, the channel, and the security. So most importantly, SSID, channel, and security, but the mode is your speed. And that is the age of the equipment. So let's talk about this first. Mode, wireless mode, the oldest, most compatible. So you're going to find that older medical devices might have to use a D or a G network. So that might slow down your whole network. Does that mean everyone has to go at the speed of D or G? Yeah, actually, that's exactly what it means. Except for a new technology that's coming out. This is something I'm really excited about. This is called AX. AX can do something they call MUMIMO. I'm not kidding, that's a new term. MUMIMO. Multi-user, multi-in, multi-out. I can actually chop up channels, do 8 transmitters, and have a conversation with one person on a B speed and have a conversation with other people at higher speeds simultaneously. That's actually pretty cool. That means that this thing is built for using a lot of different people simultaneously. What I've just told you is every one of your wireless transmitters is going to be replaced in the next 2 years. Your networking people are going to not like that. But customers are going to love what it does. So SSID, we'll talk about that. That's all these names. Notice where it says your company message here. That's actually the name of the wireless. Notice you do not have to broadcast a network. There might be at some point in time a setting that says do not broadcast the SSID, do not set out your name. And if that's what you set, then you see on the right here where it says other network, that's what it looks like. It's a hidden network. You can actually use the SSID as a proof password. How cool is that? So SSID isn't just a setting, it's just a name. You just put in the name, it's the name everyone sees. Like for example, when you do a scan and you see Marriott Conference, that's the name of the SSID. Channels are fun. Channels are like, I had one student explain it beautifully. You all are going to have to excuse me for this. They say that they're like stalls in the bathroom. You've all been to the bathroom before, right? So you've probably been in a public toilet. Well, there's 12 stalls. Sad thing. In stall number 11, there's 17 people trying to use that stall at the same point in time. That's bad, isn't it? That's uncomfortable. I'd like to use stall number 8, right? This is how that student saw channels. But it was beautiful. It was actually extremely efficient. You know, they're just bathroom stalls, folks, and you don't want to use a stall with someone in it already. So you do something called a site scan. If you see scan on your settings, you say scan, it comes up with a list, and it shows you the channels that are being used. There are 17 people trying to use the toilet in the same toilet. This is what it looks like when you actually look at the channel frequencies. This is coming to me from a program called Insider, INSSIDER. You know, SSID being the name of the network. It's called Insider. So this is what it looks like for a network scan. Now, this is pretty standard. You see, we've got a lot of people that are trying to use the same channel. That's when noise becomes a big issue. They're literally trying to shout over each other. Actually, that's how wired works. Wireless shuts up and waits for a break in the transmission. And then when no one else is talking, then they talk. They take turns, they're nice and cool, right? Problem with that is that's slow. Wireless is by design inherently slower than hardwired. Because wireless does a collision of CSDD. There's collision detection, collision avoidance. Wireless does collision avoidance, waits for people to be quiet, and it talks. Here's the problem. I did this scan, by the way, at my office at TSTC. What is this green one here that says that little dotted line at the bottom? That is an iPhone. That is a wireless hotspot. Does this mean that everyone who's got a wireless hotspot squatting on their phone is going to interfere with your wireless? Yes, that's exactly what it means. The FCC had a ruling in 2018, I want to say it was, but it was 2017, where they said it is illegal for you to interfere with that. If someone comes into your hospital and they are transmitting a Wi-Fi, it is their right. You can't do anything about it. So whatever you're doing is not as important as that paid service, so says FCC. Isn't that nice? So you guys are going to have to deal with the fact that you've only got so many channels. You've got channel overlap. So even though there are 12 channels, it's going to feel more like there's 3. It's going to feel more like there's 3 channels. On top of it, not only does it feel like there's 3 channels, everyone's going to transmit in this. I love to stay, if you want to stay, we'll go through it. But I've got a network scanner, and in this place, there is at least 50 transmitters. I'm not exaggerating. It is just insane. So, and then you get weird stuff. This is this big one here, this big one that's spanning from channel 2 to channel 8, the yellow one, that is a N broadcast. In order to get faster and figure it out, well, just broadcast on 2 channels at the same time. That'll instantly double your speed. And it did. But it also halved the number of channels. So N broadcasts are horrible. Now, with AC, they went to a 5 gigahertz band, and that's what you see all the way over on your left. That is a much wider selection of channels. Notice right in the middle, there's something that the FCC wouldn't license you. So you get the top portion of the band, you don't get the middle portion of the band, but you get the bottom portion of the band. So that's what a 5 gigahertz looks like. So let's move on, and I know I'm running out of time. So security keys. There are generally 3 different types of security. WEP is oldest and most compatible. WPA is the first one that used a passphrase instead of a hex key. What is a hex key? This is a hex key. That one that's right in the top right. There's where it says key number 2, and I got it boxed in red. Imagine typing that for your network password. That really ticked off a lot of people. But you know what? When we were starting on Wi-Fi, this is what we had, and it worked. So no one liked that. They were like, well, can't you just use a word for a password? So yeah, okay, we came up with WPA. WPA uses a word for a password, which is nice. WPA, unfortunately, is a little, what's what you might call recursive, but WPA repeats itself. And when you're a hacker, repeating yourself is bad, because that gives them an opportunity to see it happen. So we came up with WPA2. WPA2, essentially, I like to tell students, think of it like double encryption. So almost everything that we use nowadays is double encrypted in WPA2. The problem with that is you don't use new technology, do you? You use older stuff. And because you use older stuff, you might have to use WEP. And WEP's going to be really fun because that password is 26 characters of hexadecimal. Yeah, isn't that fun? And this is what it's like. Hey, what's your Wi-Fi password? Okay, you ready? It's 1, 2, 3, whatever you want. 4, you get the point, right? And it's like that. Now, WPA2, does that mean I can't write a whole bunch of random stuff? Yeah, you can do a bunch of random stuff. You've got a whole sentence. You've got like something like 128 characters to use. It's almost half a tweet. Right? No, I mean, seriously. Oh, and we've also set a timer on this encryption. We change it every so often. And let's go back to these settings right here. Notice down there you got group key renewal. Notice I got security WPA. It's just dropped down. Notice I got my password that I put in here. These are just simply drop downs. I will say this for wireless mode, client is not what you want to select. What you want to select is access point. Access point is to be the central link or hub of the network. And essentially a wireless functions as a hub. Remember, a hub repeats the broadcast to everyone. And it's the lack of security. So this is really, I think, a great place to end. Because this is what you need to know on your wireless settings. Keep in mind, wireless, we're just replacing a cable. Only really 4 things: mode, name, channel, and encryption. Think you can do that? It's not terrible. Okay, so I know I ran over a little. I'm sorry about that. The question was in the first part to go with TCP/IP, yes or no, and I didn't know where my timing was. So I should have rolled TCP/IP. But if you want to stay and experiment a little, that's fantastic. Otherwise, go get some lunch. Thank you. Oh, good. Yeah, I knew I could do wireless in 10 minutes. Oh, I was on roll. Okay, very good. We'll go ahead and turn off the mic. Thank you. All right. Yes, sir. There is a lot of stuff. And the first bit, really, I wanted to go in and delve into the basics of networking, give people some foundational stuff. And it really was important to go through that foundation. This was an advanced course. I mean, we went through that pretty quick.
Yeah, there's a lot of It's a lot to go over.
But that's okay, because we'll have this presentation posted, and in fact, it's already posted. I got these right off the website to make sure that I was. I'm not getting terribly technical. I just want to use WannaCry as a backdrop, and then talk about how we can handle and mitigate this. And frankly, I'm going to go ahead and I'm going to summarize a great deal of work from other people. So and sort of a mashup of a lot of different concepts.
Are there specific researchers that you'll be referencing?
Yeah, you know, I forgot the guy.
Marcus.
The gentleman that's out there at University of Michigan.
Malware tech.
Ron or something like that.
Marcus, malware tech when stopped the WannaCry attack.
Yeah, you know how he did it?
Yeah, he changed the domain.
Yeah, he did the DNS.
Yeah,
he changed the DNS for the region.
He got a binary, reverse engineered it, broke down the domain generator algorithm, and was like, oh, this is going to be the next address.
Yep.
Let me just buy it, like it's free.
There you go.
I met him a year and a half ago.
Yeah.
Over at B-Sides.
It was a genius move.
That was smart. Yeah. He's smart dude. And now the more ransomware is getting a little more advanced.
Well, we're going to see more and more ransomware. I think as people realize the value of medical records and the amount of traffic that we're pushing to the web, you know, based on what we had today, you know, you understood we're pushing a lot of this traffic to the web. It's going to represent as certainly a vulnerability. And so I think that's one of the things that I'm scared of. You know, we have an obligation, a legal obligation, not just a moral obligation, but a legal obligation to protect this information.
Right.
And unfortunately, once they figure that out, then it's like, well, how much is keeping that hush to you? You know, I'll take 10,000 records, and you know, each one is a $10,000 fine. There's $1 million, so pay me $250,000, and I'll give you your record back.
Yeah, it was Landon got hit as well. They got hit, and I think they had to pay up, I think it was like $50,000, but they cost them like $250,000 for the infrastructure to have to repair the damages. The line, so it's like, they take the money and it comes after because they have to fix everything.
Yeah.
But yeah, so I work for Simulate, and we help mitigate some of this risk and stuff like that. So we actually not only deal with all devices, but then we know like all the kind of connections they're doing, but internal, outbound, or whatever.
Cool.
Also, like we also see like all these devices doing SMB to this device or whatever. Also the versioning.
Yeah, and SMB was a huge exploit. For WannaCry. That was and you know, a lot of things had to change because of this that a lot of people didn't notice about. You know, Google had to abandon Drive and redesign and come up with FileStream. And they had to completely change that entire infrastructure side of things because of it.
Yeah.
You know, because people used them to perpetuate from machine to machine.
Oh, they still use AWS as S3 buttons to do the same for botnets as well.
Yeah.
Again, my background is information security, cybersecurity. Like, it's not live. I love learning about it.
Well, then you probably even know more than me. I'm just sitting there trying to piece together what I'm getting.
Yeah.
And it's a little hard because when you're in the instruction, and I see you there. I'm going to get to you. It's a little hard when you're in instruction. You're sort of on the sideline. You know. So, real quickly, man. What do you?
Just on the things between hubs and switches. What really affects us, I'm out in everything. Hubs are dividers. And what we found back when we only had hubs because you couldn't afford the switches because they're $1,000, is you get area around 10 or 100 megabits.
Yeah.
If you had, we actually ran into this, we had somebody put a 16-port hub.
Yeah.
Plugged in all of those, and they said we're getting as a 1 megabit transfer rate, and the machine was shut down.
Yeah, because you have to move at the speed of the slowest.
Yeah. Well, yeah, it just sets there divided. So if you had 100 megabit, and you had the rest of the 10s, you're running out of 10.
You're running out of 10. And some devices are okay with that, and some devices aren't. The older devices are the ones that, the software is just written for that. I mean, they're just, they run at 10. And so, sometimes you have to be sort of insulary on it. And if that happens, then there's nothing wrong with putting the router in between the device and the other side of the network, and then run on one side 100 or gigabit, and then run 10 on the other side. If that's what you have to do, that's what you have to do.
Well,
You know?
switch them out to switches, and then you got
Yeah.
switch to the port whatever it needs to those ports.
Yeah.
And that was our
Unless it's a Cisco. Cisco sometimes they mandate, you must move at this speed, Oh, yes.
And then I said, I still want my Cisco.
Yes, well, because they shove, and then there's half duplex and full duplex.
Right.
And then the duplex is an issue, and conformance statements, they mention all this stuff, they structure all that stuff down. So you really have to get into the granularity of your conformance statement and match up every device, and I don't think anyone really is doing it, because it's a crap ton of work,
Yeah, well, and we get the IT department's employee. We went from Cisco to a new set of routers, and they never thought about asking, do we run other things than Windows? And we go, we run Unix and Linux. Well, that router doesn't work good with Unix and Linux.
Mhm.
And so it was shutting down all kinds of older equipment. And it's like, guys, you can't do that. And I go in and throw a switch in there, and they go, you can't put a switch on our network. And it's like, tough. This was here long before you, unless you want to show up.
Oh, this illustrates a really great point of, we need to approach the problems together.
Yeah.
And I think that's a time to engage the management chain at that point, is because, they're supposed to be the grease that lets the components move together smoothly.
Oh, yeah.
And if they're not doing that, then that's one of those things where it's, we need to revisit what we're doing with this,
You said you're a teacher?
Yes.
I'm actually playing from around here. I studied in SF State, then I started up a hacking club, so I got all the computer science students, and I was like, okay. So I worked in the industry for a year, and then I came back to school, and I was looking at computer science, and like you guys know what we can do with all this stuff, and students were just bored, they didn't know, so they never saw the types of careers that are in cybersecurity, information security. So I was like, okay, so let me make a club, I'll make some servers, I'll set them up, you guys can just hack them, I'll show you how to hack them, it's ours, it's okay. And then I'll teach you how to do this, and then build these billable skills so that you can apply to companies and be able to do that. So
one of the things that I recommend that our students do a lot of is, you got to protect against script kiddies and YouTube.
Right.
And so if you're not on YouTube looking at how to hack into things, you're getting left behind. And unfortunately,
yeah, and it's one way to start.
Yeah.
To be exactly feel like you don't know anything, you're doing what everyone else.
Do what a 5-year-old would do.
Yeah.
I mean, because they have absolutely no fear of it. They haven't learned to be afraid of it. They just go on, they start asking YouTube, hey, how do I do this? And then, here's all these helpful links. And YouTube's full of, hey, this is how you use Cain and Abel, and this is how you set yourself up with a man-in-the-middle attack. And here's how you de-authenticate, and then force people to log on to your device and reuse it. And now you're starting logging it. And here's how you Wireshark on top of that. And then here's what, exactly. Now let's start running a log, and let's see what people are broadcasting in the clear. And this is why they do it. All right. Oh, heck, I'm sick of it. Just flood it with de-authenticate. I mean, we're done now. Just shut everyone down.
I actually probably should. That's mostly managerial. It's more like managerial.
Look,
I have because I'm in managerial.
it's in my, it's right behind me, isn't it? I didn't want to run. Here's gentlemen, here's my first card. This is actually a side business that I'm doing. That's craft brewing shop. I'm showing people how to make their own beverages. Every beverage.
Yourself store record right here.
Yeah.
He has tons of.